Alright, sick. Okay, wait, I should probably close my door. Wait. Let's see. Okay, so this is a video on it has to do with how far away is the horizon. Have you ever wondered how far away it is? Well, you've probably heard, maybe, if you watch a recent Vsauce video. Well, it depends on your height, because then the taller you are, the further you can see, but, what do you call it? It depends on your height, but, for most people, it's around 5 kilometers or less. So, I am going to show you how you can actually calculate it using paint. So, there's a cool thing you may not have noticed. So, you can actually think about this nice right angle triangle here, and it really makes it easy. So, what you want to do is you want to find the distance from your eyes to the horizon, right? You want to, that would be a straight line distance, and that's what I call L here. L is the straight line distance from your eyes to the horizon. And the ray of light that is just at the horizon would be tangent to the horizon, as in it would be parallel. At this point right here, it's parallel with the Earth, so therefore it's perpendicular to this line, radius, the radius line. So you actually get a right angle triangle here, and you can use Pythagoras Theorem and relate the different sides of this triangle to find L. So we actually know the height of the person, which means that this is the hypotenuse. It's the long side of a right angle triangle, and it is r plus h, the radius of the Earth, plus h, the height of the person. Okay, so this length is r plus h, this length is r, just the radius of the Earth, and this length is L, the one that we're trying to find. And Pythagoras theorem says that this side squared plus this side squared is equal to the hypotenuse squared. So a squared plus b squared equals c squared. In this case, I'm going to make a L and b is just going to be r. These two arms of the right angle triangle, if you square them and add them together, you should get the hypotenuse squared, which is r plus h squared. So you have this equation thing. What I'm going to do, you can minus r squared from both sides and then square root both sides of the equation, and you actually can solve for L. It's very easy. So if you want a simple, really quick calculation to figure out what's the straight line distance from your eyes to the horizon, that would be, L is equal, it just depends on the radius of the Earth and your height, and you can use Pythagoras theorem, and this quick little equation right here, it'll tell you the perfect straight line distance to the horizon. But that's the straight line distance, this L. What if you want to know what it takes to walk there? How long does it take to walk there? What is an arc length? This is an arc length. Well, there's another equation that you will have to think about. Well, here's the thing. When people use angles, you can think of them in degrees, but radians, they like radians because it's like a way of depending on the radius of the circle. I don't know. Okay, so I have an equation right here. It kind of makes sense, but it basically, an angle is the arc length around the circle divided by the radius. So the bigger the circle is, it means less. What does this mean? Well, you can rearrange this equation, and it means that you can find arc lengths and stuff like that. And an arc is just, a piece of a circle. So I don't know how you can say this, but basically, in radians, when you're talking about radians, those angles, 360 degrees is 2 pi. The cool thing about that means if you multiply 2 pi by the radius, it'll tell you the circumference of the circle, right? Well, what if you want to find the circumference of only 3/4 of the circle? Or what if you want to find, basically you can get any angle and you can find just basically a fraction, like an arc length of the whole Earth. So if the angle is equal to the arc length divided by radius, that means that the arc length is equal to the radius times the angle. So you can actually figure out this arc length, this black line using L. So if you know sine of theta is opposite over hypotenuse, well, the opposite is L, and the hypotenuse is r plus h. So sine of theta is equal to L over r plus h. And then you can do the arc sine of both sides to cancel out the sine on this side, so you just have theta left. And arc sine of L over r plus h, that tells you what this angle is here. That's nice. So you can figure out L quite easily using this equation. And then you can put it into here, L over r plus h. It'll tell you what the angle is here. And then, with that angle, all you have to do is multiply it. Let me try. So basically, the entire distance, if you really wanted to get it, would be, this is distance like walking distance. It would be equal to, what the fuck would it be? It would be the radius of the whole Earth times the angle. So r times, I'm just going to write r theta because I don't want to write all that stuff. But basically you can plug this into this, and you can plug this equation instead of theta, and you can get the whole distance. You can get the whole arc length. And that's pretty boring, I guess. No, wait, it's actually pretty great because of how simple it is. In my opinion, this is some nice math, some elegant math, and I just showed you how to find the distance of the horizon. Bye bye.